more to do about promises. All right, so let me just start. Very short, but still relevant to promises, because a good real life scenario to use a promise would be when you're fetching data, especially from an external source. You could also manage data from a local file, which is perfectly fine. But I think we may have seen an example where there was some JSON files. We wanted to read them in. As we're getting data back, maybe you want to do something with it, right? But that's a very common scenario where you might want to pass back a promise instead of doing a synchronous call of, hey, I'm going to go and I'm going to request this huge payload, which could be a gigantic data stream. And only then am I going to stop everything on that thread until that request comes back, all of it. And when all of it comes back, then I'm going to continue execution on my path. Whereas the asynchronous approach would be is, hey, I'm gonna request it. I'm gonna let the main thread continue, and as the data is coming back, we're gonna handle that data coming back in an asynchronous manner, so that allows us to do other things with our application, right? Because we may have multiple asynchronous requests being fired within our page, and we certainly don't want to stop the page from loading just because we're waiting on a slow poke coming back with a big data payload, right? So that's a lot to talk, that's a lot to say, but we're going to deal with the server in Node.js that has all this mechanism, right? Luckily enough, there's a bunch of APIs out there, and if you don't know what the API is, think of an endpoint that you can call that returns data back to you. There's a lot of test APIs out there that we can play with, meaning we don't need to build it. We can just talk to them and trigger some data back to work with. There are different types of there's different type of libraries that you can use. When you're talking about Node.js, there's a bunch of ones like Axios and things like that. But because we're talking about the browser, and because we have access to that whole web API that we've been using, right? They have a built-in feature called fetch, which if it's a very lightweight thing you want to do, like retrieve data, you can just use the built-in fetch. You don't need to grab an external library like Axios, which is very heavy, right? And it's more towards Node.js projects. I actually got corrected myself in my other job, because we needed to do some API calls, and the guy started using fetch. I'm like, hey, I use Axios all the time. Why are you doing that? And he just said, it's built in, it's lightweight, so there's nothing wrong with using the other one. It's just a heavy payload, right? Anyhow, step back a bit. There is a concept called AJAX in the web. If you don't know, AJAX has been around for a while. It stands for asynchronous JavaScript and XML. So asynchronous JavaScript and XML is what AJAX stands for. And it is a set of web technology to send and receive data asynchronously from the client or server. When we talk about the client, we've been using it means the caller or the user interface or whatever mechanism might call for data, right? So for our full stack 2, our client is the web browser, but it could certainly be a desktop application. It could be a process that's running on the server. A client can be many things, but for full stack 2, our client would be the browser. So previously, before we had this technology in between the server and the browser, say the client, it was called AJAX to handle requests, because you can imagine we're firing requests back for data. We need a response. We need a way to handle it. So before we used AJAX, and it is done behind the scenes. You don't need to reload the web page. It uses JSON, which is the JavaScript object notation. It looks like an object literal. It's basically the format of a payload, right? So we already were looking at objects. We were already going through what an object literal looks like, right? And we already may have mentioned that JavaScript now is universal. So why not use that format which we'll call a JavaScript object notation, which is the object literal. It's a very nice way of packaging up data with the key value pairs. A lot of technologies adopted it because it's like a nice standard now. The payload is very small because it's just text, right? It's not very heavy. Where in comparison before was something called XML. And if you don't know what XML is, I don't have an example at the moment. Let me quickly show you. If XML document, my God, it's really ugly. I gotta tell you, it looks like HTML. It looks like this. So if you can see all of this kind of deal, this is something called XML, and it's a server side, and they have a .xml extension, and the payload is very big. You have to have tags, and you have to close the tags. So you can visualize right now, we need like a menu item and a text with the file value. This kind of thing could be easily replaced by a nice small little JavaScript object with a key value pair instead of having all this extra. Because you can tell, right? These tags themselves, they contribute to the payload, right? We just really are after the key value pair. We don't need all this other syntax and markup. So, an XML document is very big and very long for what we need. And that's the older tech, right? The older transfer protocol. It's still in use in different technologies, but anyway, that's what that is. So anyhow, the AJAX was the mechanism to handle request response. The payloads, were XML, so the JSON has replaced it. Most APIs return JSON now. AJAX can also return plain text. So AJAX did have the option to return XML or plain text, right? You could switch between the two. How it would work is something like this. You would have, again, this is older, right? So you may have seen the example in the previous class where the video, the NetNinja guy was making a promise request. He was reading in a file. He was using this markup here. So the browser fires an event. It needs to create an object called an XML. Now you don't have to memorize this or know this, right? Just reference this is the old way. It would have to create an XML HTTP request object, create that object. It would have to send the request. The request would go, this is kind of a very high level generic thing. It says go through the internet. That's kind of too general, really. It makes a request. And when they say go through the internet, what they're really saying is it's making an HTTP request, which is a specific protocol we're going to talk about in Node.js. Well, we'll expand on this whole diagram much more. The server gets the request. Server does what it has to do. Maybe the server needs to do a number of things. At the end of the day, the server will respond back to the caller, which is the browser, the client. It'll return back the data. So you can imagine this would be the request. Server sends back a response. I don't have my pointer here, right? Here's the request coming in. It does some processing. It grabs some data. It responds through the internet to the browser. And really, this is the same browser. So I don't know why they did something like that, right? It's one caller. But I guess it's showing the actions of the request and the response. So then the browser processes that data response and then updates the page content, right? So you have that kind of thing going on. So very high level. We'll dig deeper into this, but yeah. So what was I going to say here? Right. So how this works is the request is being sent, making that AJAX call because it's using this older HTTP request object. Data is in JSON form. Data in JSON format. So I guess if you're responding in plain text, can be fetched asynchronously is the point from the server. Page content is updated without reloading the page. So that's the key, right? This is the main thing. Prior to AJAX, I can remember working on those pages. The whole page would have to reload. You'd have to refresh. You'd have to do a hard reload, like this to get the data to load properly, right? Here, basically your page doesn't go anywhere. The data fills in as it comes in, right? As we know, with manipulating the DOM, just imagine the data coming in, the user scroll down to a certain point in the browser and the data is being populated, right? It doesn't jump back to the top and do crazy stuff like this. It maintains the position, the page state, the data asynchronously comes in. When that tech came through, web pages got really interesting, right? Before we had a very old model. So that's the key. You don't have to reload the page. We fetch the data we can fetch from a file, or we can go external to a public API, or we can call our own server. So there's lots of different ways. Right. Sorry, I will post those slides after I'm done. I'm almost done in this. I will post those. All right. Getting back on track here. So this is what it used to look like. What it used to look like was this. And again, it looks like a lot of work going on here if you didn't recognize it from before. Really what we want to do is we just want to call this endpoint, which is github.com/users. So that'll actually give us a nice payload. It's just sitting up there. So before, we can still do it now, you had to create that object for the request. So you create an object for a request. You open it. I guess that's kind of strange. You open it, but you're getting it ready for a GET request. So there's a couple number of requests, and we haven't talked about them yet. There's a GET request, which just gets data. There's a POST request, which is going to write data. You're basically telling the server, I'm either going to retrieve it or I'm going to save it. There's some other options as well. Again, we're going to go deeper into this, right? This is a primer. So in this example, we just want to get a payload. With this URL, we want it to be asynchronous. And then we have to do this we set up this handler, on load. And then when we load the data, it handles it in this function, right? So it calls it when it's ready to call on load. It checks if the status is 200. So we do have status codes on requests, and 200 is good, right? 200 means everything is good. And there's a bunch of other codes in there. So if 200 is good, we basically output the data. We do a JSON.parse and we just output it to the console. That's all it's doing. But it looks like a lot of work, to be honest. When I look at that syntax myself, it's so old, I'm like, what is it doing there, right? So let me just grab a notepad here because I want to show you what this would do here. So without losing the slide, HTTP/. So this is the HTTP request. That's the protocol. The S, by the way, is secure. That means there's a secure certificate there. I want to call this endpoint github.com/users. I just want to do that. So this is a RESTful API. What that means is I can run this through the browser and you'll see what happens. If I post this, it's gonna just give me back the data in the browser and I populate it. If you look at that data there, you can see it's an array. Inside of the array is it's an object. It's a JavaScript literal key value pair, right? And it's a nice payload. It is, if you compare to the XML, look at how very exact and specific it is. It has a nice structure. I see exactly what the keys are, login ID. If I wanted to create an app to show avatars, bunch of information on some fake users in GitHub, and there's quite a bit. Maybe there's about 100 in here. I'm not sure. By default, what they give you. Sorry, maybe there's, I don't know. You can count that out. But that's the call. My browser made it. It didn't request anything. If I look at okay, so this is another thing we need to look at. If we were to look at fetching or making requests, go to developer tools. We have this network tab and we've never used it before. So this network tab deals with all of the requests going out. So if I refresh this, you'll see there a bunch of stuff happen. You'll see it tries to grab some images, some gave us back a status of 400. It's basically giving us an error saying something, but this is what we can do when we see the network requests, right? If we look at this user payload here, we'll see that it gives us a status code of 304, not modified. So apparently it's green, so that's good. But it's basically telling us this was the URL, this was the method, which was get, and a bunch of more information in here that we don't really, there's a request header and there's a response header. Again, we'll get more into this. It has a bunch of attributes in there, but for now, we want to pay attention to this, right? So you can see API was called, get method, and all of that. So we've never looked at this tab before. This is a very simple example. If I went to my favorite site, I guess, and we looked at the network tab here, right, on this kind of site, look at what's going on. Already you can see, it's loading a bunch of stuff, right? And they're all assets like images and external scripts. However, if we went into, say we wanted to look for something, which was, I don't know, Lego or something like that, right? So if I clear this out, you're going to start seeing all these different, and you can start to see the timeline here, right? So you can see all the network requests that are being fired, and you get a little bit of a time period here, and you can actually dig into these if you were debugging, right? And if you scroll down, maybe I wanted to, I don't know, filter by API. Sorry, API. Right. So then, or XHR API, something like that, right? Then you can start to see some of this stuff, what's going on in some of these requests, right? Maybe that was the wrong one. I don't even know how to debug the site I'm working on here. There's a whole bunch of stuff going on here. That's all I can tell you, right? I think we've hidden this stuff a little bit better so people can't look at it. In the development environment, I can actually look a lot better into this. So, but anyhow, you can see a lot of stuff's going on. There's a whole history going on, right? What happened between this section here? I don't know. Start looking at it. So anyhow, there's all these tools to look at responses, and there's a lot going on many sites, right? They fire multiple APIs constantly. If I were to just, let me try to do something here while I'm here. If I want to fire this, pick up today. Okay, so there I see a bunch of APIs fired. This one fired here, a big API call. The status code was 200, which means I got data back on that GET request. And that's just one, and I can see it here, success, right? So anyhow, a lot of websites fire multiple API calls asynchronously to load many different things. Maybe this call right here is loading all these products in this grid. There may be an API call to add this kind of navigation stuff. There could be an API call to populate some other pieces here, right? A lot going on. Our example is very, very small. It's just one kind of API call. But anyhow, the network tab allows you to dig into these requests. We've never looked at that before. And getting back to my original thing, which I kind of veered off topic, was, yes, we had this concept of Ajax, right? So let me try to, I don't know why everything's minimized for me here. So this is what it looked like. And what did I want to say? Yes, so common types, status is coming back. 200 is okay. If you start getting into 400s, even on a normal web page, 400 means an error happened, right? 404 means error. 403, there's a whole markup on this stuff, by the way. If you're ever interested in this, it's like HTTP status codes. There's a whole metric, and I'm sure we'll probably look at some of these things here. So this would be a status code list. The green is good. Anything in 200 is successful. Level 400, that's bad. Level 500 is really bad. Means the server died, something in the server. So the good thing about API calls is they will actually let you know what happened by a code, and you can, respond, accordingly. Sometimes if you fire for some data and you don't get it, you don't get it. But maybe you need to throw a certain message to the user to let them know why something didn't load. So I'm going to try to trigger this request from the REPL. Let's see if it lets us do it. If it doesn't let us do it, then I will have to put it inside of a browser just to show you. All right, let's see if it allows requests. Does it? Or does it blocked? So it doesn't allow us because, of course, we're not inside of a browser, which makes sense. All right, so I can, how about this? I will comment all this out while I'm talking to you here. I need music. Let's try this. Reveal in the folder, Explorer. All right, where was it here? So if I want to open with Chrome, hopefully the browser will know what I'm trying to talk about here without errors. Let's look at my console log. What do you think? All right, so it did return what we wanted. If you can see here, I'll refresh it again. You'll see that network request go out here. If you can see it, I can expand on it a little bit. It made a call to GitHub users, GitHub API users. I got a 200 response, okay from disk. If I look at the preview, you can see I get that payload in there. So this is what the payload looks like in the response, which looks like this. Comes back in an array, right? I console logged it so I could look at it a little bit better. You see the array here, and we could dig into each one of those objects if we wanted to, right? To really look at them. But really, it was 30 items inside of an array, and we called it via HTTP request, and that's all we did. We didn't do anything else. And that was Ajax using that mechanism. However, there is a newer version of this. It's called Fetch API, which I was trying to get to. And as you can tell, look at how we have to handle this stuff. Look at it's kind of messy, right? We've been talking about promises. This is not clean. It's clean, but you'll see the other syntax, right? Like look at this. I have to set up a request on this line. I got to open it. I got to set an onload. I got to check the status manually. And then I have to do checks for the happy path, and then I got to check the status for the 400 errors, which is the negative path or unhappy path, right? And then handle those errors where you can visualize already. If we had a promise, we would handle the happy path with a dot then syntax, and we would handle the 400 in a dot catch. And you'll see all of this make a lot more sense when we look at the Fetch API. All right, so Fetch API. So Fetch is the newer standard for dealing with the HTTP request. It's part of the window object, that global object. As you remember, we have the document, we have the window. The window and the document, they're both libraries, right? So I believe I didn't cover that, but the window is part of, we might not have heard it before, we've talked about the DOM. The document is the document object. But return belongs to the BOM, browser object model. So we do have that distinction. The window is part of the browser object model. The document with all of those, content is part of the document object model. The point is they're global, and this is part of the global model, and it's built into the browser or built into the API, so it's there for you. You don't need to include it. It's just there, built in. And Fetch returns promises. So we can easily fetch data like from the GitHub using this mechanism, and it can return promises. So we can continue on with that asynchronous syntax and handle this stuff in a cleaner way. So Fetch API, this is probably from the document, provides an interface for JavaScript for accessing and manipulating parts of that pipeline, which is the HTTP, the pipeline, which is the request response model, right? So it allows us to work in that model, to trigger those requests, handle the responses, provides that global fetch method that's pretty easy way to kind of, asynchronously call things across the network, right? So this is what it looks like. It's pretty simple. If you remember the previous Ajax thing, you have a fetch, you give it a URL, that will internally return a promise, right? We know what the promise syntax is. We know how to create our own promises, so we know the concept. So we know that that object coming back is either going to be successful or it's going to be a failure. We don't have to worry about that syntax here because fetch returns a promise. We have to handle it. So we handle it with a .deniable, which handles the success path, or we handle the failure path, which is .catch. And if you can see there, why would you use a promise? Look how much cleaner that is than the previous 30 lines of code, right? So calling fetch returns a promise. We kind of have an idea what that is. In the response, so we know that if the promise is rejected, it's a network error. We can catch it, we can log it, we can do something with it. If there's no problem, it means it's success, which means it's a 200 whatever, it's successful. There's probably the server responded with a nice success code. We can deal with the data and do whatever we need to, right? So if at the very least we just want to output it to the console, we could, or we can do much more, right? More complex stuff. So, all right, so before I get into that, so, all right, going back to my original example here. So look at all this, right? That, I'd have to probably also handle else this dot status, which is the failure, equals 400 or something like that. Then, then I have to, look at, I'm already, I have to console error the fact that, there was an error occurred, on the server, what now, right? Kind of thing, right? So, but we don't need to do this. So we can, let me just revert all my copy pasting here that I did. I could try to revert if I could. So something like that, we can run that. So what this is going to say is, and maybe we don't even need to, we'll just do this, right? On window load, we're going to set this function to fire using the ES6 syntax. It's going to say window is loaded, and then we're just going to trigger off a fetch get request using the fetch API. It's going to chain it in a different way. So like this is actually an example of chaining, right? But if we didn't want to do this, okay, make it even simpler. If we just want to console log, that was actually showing something else. If we wanted to just console log that response, we can do that, right? Otherwise, we could then catch whatever the error coming back was, right? And I don't know, console.error, something like that, right? So let's refresh it. Cross our fingers, it all loads up properly, refresh, loaded, and you can see now it got the true response. So you can see it got the whole response. I may need to work with it a little bit here. We may need to dig into this, right? So you can see it already here that I did get a successful response, and maybe that's what we were trying to do with that digging into it. Let's take a look at what we were trying to do previously. We grabbed the response and then we added a .deniable, right? So we converted it to a JSON object and then we console logged that data. So let me see what that looks like. If I refresh it correctly, there we go. So if you noticed, it converted that to a JSON object and then it console logged it. Could we have done that all in the same thing? Maybe we could have. Maybe we could just console log the response.json and go back to our original. Let's see if this works. Console refresh. Oh, it returned the promise. See, it returned the promise that's fulfilled with the array. So we see we have the promise with the successful value in there. So what it's saying is if it returns back a promise that's successful, then I might want to dig into all this data and dig a bit deeper and handle that data, right? So there is a pattern with dealing with data, but you can already tell, there is some syntax things you got to dig into maybe to get used to dealing with data, which is maybe another layer of success. But you can still tack on that catch, right? And handle the unhappy path. But getting back to this, there is a pattern dealing with data, and only when you start really working with APIs, you'll learn the pattern. But common pattern in today's application is when a request comes back. Sometimes you want to sort the data. Sometimes, you have user post comments, maybe on the UI, you need to manipulate it. Maybe you need to, maybe you have users, you want to show it, the payload comes back raw. You want to, you don't want to show everything. Maybe you want to only show the first name, last name, and the last time he logged in. We have, we have 20 key value pairs. We only need 3. Maybe we need to sort the data, from ascending to descending based on the timestamp. Maybe we need to filter out all the users that are inactive, right? So what you can do is you can see a common pattern that happens is you use all those array methods we learned, like .map, .filter, because sometimes you need to manipulate that data stream coming back for presentation in your screen, in your content, right? So let's take a look at that, because there was probably a more, so if I look at this one here, so you can see here we fetch it, we get the response, we convert it to JSON, and then we iterate through all those responses. And as we're doing it, we're mapping just the name. So we're pulling out the name, and then we're just going to console the name. That's all we're doing here. So let's take a look at that. And if you notice, the URL is external, like we put it inside of a variable, so it's not inline, just to save some space. So let's take a look at this one. Where was I here? If I refresh this here. So we just pulled out the name. So you can see here I have an array now of just one property key value pair, and that was the name. I forget exactly what that was here. I guess it was the name of the repository. So how did we do that? We got the response, successful response. We converted that object into JSON. And then we handled that. So that returned a promise. And then we iterated through using that thenable with this function. This is actually a function, right? It may look a little bit confusing to you because it doesn't have the function. It's using the arrow syntax, but that's a callback function. Don't be mistaken, right? It is actually like this. This is the vanilla JavaScript syntax for it, right? It is actually like this. Sorry. It is the callback function. This is also the callback function. That may be confusing to you if you see that lambda or those arrows everywhere, right? It basically throws us off. Right? That's what that looks like. It's a function. And again, if it's too confusing for you in that way, you could extract those functions and give them a name that makes sense to you. Something like, handle JSON equals this whole function here. Something like that, right? You could do that. And then give that by reference, then handle JSON, right? And then all of this could be, I don't know, map data or something like that, right? Something like this. So then you have now I may have probably missed something here, but I'm trying to show you is that you could have something very clean that tells you, hey, this is what this is doing. It's fetching the URL. It's parsing the data or handling the JSON data, and then it's going to map the data. And that's all that this fetch does, right? Which is a lot cleaner than this. I don't know what this does. I mean, I know what it does, but it's a lot of work to do the same thing, right? So that's what that was. I mean, let's see if that actually works, to be honest. I might have missed something, maybe not. Yeah, so it doesn't understand map because I'm missing something for sure. It's probably, yeah, whatever. I'll fix it and show it to you. But anyhow, the point was you can extract out. These are just functions inside. Don't be swayed by the arrow syntax, right? The ES6 syntax. It's just meant to be cleaner, but if it's not cleaner for you, you can certainly put those functions inline if you want to, right? And what I mean by that is you don't need to put them outside. You can keep them inside like that, right? Was that all? I think that was almost it. Yes, it was almost it. So again, I always think it's going to be short, but it's not. Let's let this other guy talk, and it's 7 minutes, and he'll talk about functions, Dutch API as well. And we'll watch Mandalorian. Why not? It's already here.
No audio.
Sorry, no audio?
Yeah, can't hear.
All right. No audio. All right. So why did that not happen? All right. No audio on the share. Oh, well, you saw it at least. Let me try this again. Okay, I think it's when it's recording. Stop recording.